So we have been working on 2 variables. Now we're going to do 3, okay? So hopefully that warms you up a little bit, gave you the basic idea how to do this. This is, even though it's only one more variable, it's more than just a little bit harder. It's a lot of harder, if you want to say that, okay? So here we go. Let me do this. Let's write it down. So we have 3 equations and 3 variables. We've already learned how to do this with substitution elimination. And on the quiz, as you see on the lesson plans, the quiz is on Friday. It's 3-3 and 3-4. 3-3, I think, was doing substitution elimination with 3 variables, I believe. Is that correct? I think that's what it was. So you will have to do that on the quiz, and you're also going to have to do them with matrices. So you need to know how to solve these things both ways. In fact, the very next lesson that we're going to do, probably when you get back from your trip, is we're doing 3 variables, we're doing matrices, but we're doing them a little bit different. Okay, even though it's matrices, we're going to use something called a determinant. All right, maybe you learned determinants in Algebra 2. I don't know if you did or not. If you didn't, it's fine. We're going to learn it from scratch when you come back from your trip, and we're going to learn it in a different way. So in all, there's going to be 3 ways to solve these equations. All right, sometimes one way is easier than the other, but it's always good to have a variety of ways to do this. So here's the first one that we're going to do.
If he's teaching it, he's going to do it on the test. He's not going to do something for no reason. Yo, shut up.
Should be writing this down. A lot of talking. All right, so this is your system of equations with 3 variables. Now again, if I just gave this to you and just said solve for x and y, if it was me, I probably would not automatically go to the matrices to do this. Okay, some people would. Some people like them a lot better. I probably would do this by substitution or elimination, especially the way it's set up right now. I could eliminate the x's very easily. It wouldn't be, I think it would be a little easier just doing it the old way, all right? But we need to learn new ways. We need to be open to doing things differently, because sometimes doing them with these matrices, sometimes, depending on the problem, will be a lot easier than it would be trying to do it, we'll call it the old-fashioned way, right, by substitution elimination. So that's why we're doing it. Because you may look at, when we're finished this problem, we're not going to do it just with the x, y's, and z's, but if we were and you compared it, my guess is that doing them by matrices might be a little bit, I don't know, maybe a little bit more work. Maybe, I don't know. Let's give a name for this. We said it in the title. We said we're going to solve these by matrices, but they actually have a name for it. What we're going to do is called the Gauss. I'll just, it's not going to be on a quiz or anything, but it's just so that you know. It's called the Gauss-Jordan. Now, I don't know anything about Mr. Gauss and Mr. Jordan, but this is what they call it. I guess I could have looked them up, but I didn't really care, to tell you the truth. Elimination. All right, so they call it, and that's kind of what we did on those 2 variable things. I just never gave you the name, but it's called the Gauss-Jordan elimination method. All right, if you wanted to look up on YouTube, that's what you can search in, okay? Solve 3 variables with the Gauss-Jordan elimination, or you can just put Gauss/Jordan or -Jordan, and I bet you anything, there'll be a ton of videos that pop up. People just love to show how smart they are on the YouTubes, all right? So they could do that, and you could watch. Maybe you see somebody else's explanation, you like it better than my explanation, all right? Which is a reason why I watch these videos on YouTube, because that's what I'm trying to do. I'm trying to look at somebody's explanation, and I'm like, you know what? I really like how they did that. Somebody else did it. I'm like, man, I wouldn't do it that way. That's way too confusing. And I've done that. That's how I watch my math videos. I look to see a good method to do it. So I'll tell you what, let's do this first, and then I'm going to show you what our goal is. Do you remember what our goal is for the 2 variables, but 1s and 0s? It's kind of going to be the same thing. It's slightly different, all right? But it's kind of like that. So let's write this out as our matrix right now. You should know how to do that. It's exactly the same way as when we did the 2 variables. So that first row right here. So row 1, what am I going to write in row 1 for my matrix? I'm going to put, not an x, a 1. Put the coefficient, right? Let's put the coefficients, and then we'll put a little bar. You don't have to put the bar. I don't even think the book does, but most places, when I first learned how to do this, we always put the bar. And a lot of people on the math videos, they put the bar. But anyway, so we got 1, and then what's our coefficient right there? It's -2. Our next one is it's -1 because that's a -1z. Don't forget the negatives. That's a mistake that students make quite often. All right, so you got to make sure you put the signs, whatever the sign is, you got to put the right sign because that'll start you off on the wrong track, and there's no way you're going to be able to get the answer unless you make a second mistake, maybe. I don't know. So what's after that? A 6. And again, the bar or the book doesn't put the bar there, but we'll do that at the end. I just kind of like to separate the x, y's, and z's with what they're equal to, but you don't have to. All right, let's do the next one. That's easy now. That's 2. That's 2. That's -1. That's 1. And then we got -1, -1, 2, and then 1. All right, I'll put the little bar just to kind of separate our x, y's, and z's. So what we're trying to do here, let me put some letters. Here's our goal. Our goal is to make it. Now, technically, this is a matrix, so matrix always has that brace right there. We'll do that for the first one. After we start going with this, I'm not going to put the brace. It just gets in the way. It's too much to write. We don't really need it that much, all right? But they always put the brace right there. So here's our goal, and I'll put the brace on this as well. I'm going to put oh, you know what? I'm looking at the wrong thing. Hold on. Give me a sec. Oh, there we go. That's what I want. So here's our goal. These represent numbers. These aren't variables. These just represent numbers. And then this is the answer. Like there's our little bar right there. That's the answer to the x, okay? And then we have this. Put a 0. I'll put an E and an F right there. And then a Y. You can use any letters. I just happen to use these letters. Put a 0, 0 right there. Make that an I and make that a Z. So this is our goal. Really, the thing that we are concerned about more than anything, actually, you know what? It doesn't have anything to do with that, but that's a good thing. I actually took a class in college, a computer class. What would we call it? I think it was something else though, but it was about binary. It was about ones and zeros. We had to do a bunch of stuff. I think we actually did we do a calculus problem? I think we did an integral just using ones and zeros, I think. Or maybe that was another class, I don't know. But anyway, I did have a class on that. But what we're trying to do right here, I want these to be all zeros right there. Okay? Xavier, you're going to leave in a second. No, but don't is the problem. I'm trying to talk. It doesn't matter. I'm just giving you a little anecdote. It doesn't matter. Just sit and listen to me. So what we're trying to do is put these 3 right here to be zeros. If we can do that. Now look, why do we want these 3 to be zeros? Why do we want these 2 to be 0? Because really, what letter is that? What variable? It's not an I, it's a what? That's a Z, isn't it? Okay? If I know Z, then I can substitute in for this F and get a what? Get Y, right? Solve for Y. You follow me on that? And then once I get this Y and this Z, then I can substitute in for here and get X, all right? So this is the minimum amount that we want to do. I don't think this is technically the Gauss-Jordan elimination, all right? I was going to show you another way, but I'm going to do this way first, and then I'll show you another way, all right? So, yeah, so the Gauss-Jordan technically would be this. It would be 1, 1, 1 right here, and then everything else would be zeros. But we're going to start off a little bit easier, I think. I think they might just call this the Gauss method or something like that. I'm not really sure, to tell you the truth. I'm not that up on this stuff. But that's what we're going to try to do right now. We're going to try to take this and make those 3 things zeros. All right? So let's get on with it. I think they call this just Gaussian elimination. We just want to get one variable by itself. Once we get that one variable by itself using this stuff, then the rest we can kind of like go back and do it like the old-fashioned way. So once I get z by itself, z is equal to whatever, then I can plug in, if that's a 0, then I can plug that in right there and then solve for y. Once I get y and z, I can plug it back in for this, and then I can get x. You'll see in a second. So let's just do it. Let me just rewrite. I just want to put them in a position where I can do some stuff with them. So I'm going to keep that there for our original problem. Then I'm going to scooch everything down. I'm going to put this here, just slide it to the left a little bit. And then we're going to actually do some things with this. So let's put it in red. So here we go. So again, we want this to be a 0. We want this to be a 0, we want this to be a 0, and we want this one to be a 0 right there. So where do we start? Well, just so I can stay with my notes, you could probably start in a couple different ways, but I'm just going to do this. I want this right here to become a 0. All right? So what I could do, I could just, besides multiplying, what I could do, remember, if I just add these columns together, what's that going to turn this into? Right, if I just add the first column to the third, or not column, row, sorry, the first row to the third row, what will that do right here? That'll make it a 0, won't it? So let's do that right now. All right, let's just add. I'll put a plus right there. So add, we'll say R1, row 1 plus row 3. Everybody with me on that? Okay, we'll just do this as easy as we can. I think I combined a couple steps on the first one on mine, but we'll just go one step at a time. So if I add these together, I just keep that first row the same. I keep everything the same except for the third one. Okay, I'm going to add that whole row to this whole row right here, and then I'm going to change what I get on that third row. So that's that. Okay, now let's do it. 1 plus negative 1 is what? 0. That's the whole idea. Okay, that's the whole reason we added them together, so that it would come out to a 0. Everybody understand that? Okay. And then let's add all the other stuff. What's negative 2 minus 1? It's negative 3. What's negative 1 plus 2? Because we're adding the first row and the third row. So it's positive 1. And then we got to do it to this one as well. 6 plus 1 is 7. Okay? I'll put that little bar right there. All right, so we got a 0 there, so that's good. Where else do you think we can get a 0? Pretty easy. Probably right here. So let's do this. So I can make that a 0. How can I make that a 0? Yeah, but then I'd have all zeros and I'm losing all my variables. So I don't want to do that. Good. Multiply the top by negative 2. I got to do it to everything, right? I'll put it in parentheses. Multiply everything by negative 2. And then do what? Add it to this column right here. Everybody see that? Because if I made that into a negative 2 and I added to this, then this 2 will go to a 0. Right? It's kind of like what we did, right? It's just, we just do it a little bit more. That's it. It's almost identical to what we did with 2 variables. We just do it a few times more with this. All right, so the thing I multiplied by, I don't change that one, okay? I only change the one that I'm trying to change, okay? I'm adding it to this to make that a 0. So the top stays the same. Even though I'm multiplying it by stuff, it eventually just stays the same. And then the bottom, the third row, I didn't change anything with that. So I'm going to keep it like that, all right? Actually, I could just do this in our head. Can you do that in your head? Let's see if we can, well, I'll tell you what, we'll write it down right here. So this is what? Negative 2, and then what do I do to that? What do I do to that second row? Add it, right. So add 2. So what's negative 2 plus 2? It's 0, so that goes right there. That's the whole reason why we did that. The whole reason why I multiplied the top or the first row by -2 and then added it to this, so as this could become a 0 now. Understand? Because remember what our goal is, to make this one, and this one right here zeros. So we're like 2/3 of the way done pretty much. But we got to do the rest of them too. You can't just do it to the 1. You got to do it to everything. So what's this? -2 times -2, which is +4. And then what do we do with that too? Add it, so that would be a 6. It's not hard, is it? No. What do we get here? -2 times -2 is +2, and then we add it to -1, so it's just 2 minus 1, which is 1. Let's do the last one. 6 times -2, which is -12, and what do we do with that one? We add it, and then you get -11. So there you go. We can put the bar there if you want to. Again, it's really not needed. Yes. Why does it stay the same? Because the one that you're doing the stuff to just stays the same. I'm trying to think of a really good reason, but that's an easy enough reason for you to understand, okay? The one that you do the stuff to, that just stays the same. Our goal is to get rid of this one, right? So this row is the one that's going to change. It's the other row does not change. Even though technically we are multiplying it by something, right? And then adding it, but in the next step, it just stays the same. Yeah, that's a good way to look at it. You're only changing this temporarily, but it's going to stay the same. It's this one that we want to change, so I keep the others the same. All right. So now, which one do I want to get rid of here? Right, the -3. So I did something that you don't have to do, but let me see if you have to do it or not. Oh, I see what I did. No. Let's just. But see, then this turns into a 0. Okay, so watch. The easiest way to do this is this. I think I will do the way that I did it in my notes. Right. So watch what you're going to do. Watch this. So everybody look up here. You could multiply the bottom by 2, right? That'll be what? -6. And added to that, that'll be what? 0. But then this is a 0. I wanted this to be a 0, didn't I? So what we can do in the next step, since I realize that this is going to be a 0, I could just switch the second and the third rows, and then I'll have my 2 zeros down here.
Wait, you can't just go the other.
You could flip them right now if you wanted to.
No, but not flipping them.
Well, you would have to multiply this by a half. So you could do that. All right, so you could multiply this by a half, but then you got, fractions, and you're going to have -11 halves plus 7. Do you really want to do that? No. So what I would do, and this is what I did when I took my notes on this. This is what I did. I multiplied the bottom by 2. You'll see in the next step why it works. Okay, you might not see it right now, but I'll show you. So you multiply this by 2, multiply that by 2, multiply that by 2. And then we're going to add it to the second row. Now remember, the bottom row is going to stay the same. The second row is the one that's going to change. But you're probably thinking, Mr. Hammer, I thought you wanted to make this one a 0, not the 6 into a 0. But what we're going to do in the next step is we're just going to change the second and the third row, which we can do, all right? Because all we're doing is just adding stuff together, right? It doesn't matter what row these things are in. I'll show you in a second. So let's watch. Yeah, go ahead. You could change the rows right now if you wanted to.
But like what I did was at the start, I multiplied the bottom by 2.
Right.
And then added those, and then I changed
No. You don't want to do that. No, you can't do that. Okay, you have to add it to this row. Okay? I can't give you a good reason for it. I'd have to really sit and think about it. But that's what you want to do. So let's do it. Here we go. So 2 times 0. Again, we're going to add it to the second row. So the top stays the same. So let's just write that down. So that stays the same. And the bottom's going to stay the same, isn't it? The third row. So I keep that the same. All right. So what we're going to do is we're going to change the second one. So what do? 2 times 0 is 0. 0 plus 0 is 0. That was easy. So that's good. So that's still a 0. Now, here's the one we really wanted to do. This is the one. This is going to be 2 times negative 3, which is what? Negative 6. And then plus 6, which is 0. Okay, there's our third 0. Problem is, it's just in the wrong spot. But we'll fix that in the next step. What about this one? 2 times 1 is 2. Plus 1 is 3. So that goes right there. What's this one? 14 plus negative 11 or minus 11 is 3. So I'm multiplying the bottom, the third row, by 2. And then I'm adding it to the second row. And I'm replacing the second row with what that answer is.
So we're just flipping it?
Well, we're not flipping it yet. We will in a second. Everybody see that? Now look right here. We really wanted the 2 zeros to be in the bottom row, didn't we? The third row. I should say the third row. So let's just change the order. It's perfectly fine to change the order of them. So let's write it a little bit nicer. So 1, negative 2, negative 1, 6. And then let's put the second row or the third row into the second row spot. So I'm going to go 0, negative 3, 1, 7. And let's take the second row, move it to the third row. So this is going to be 0, 0, 3, 3. That's all I did. Here, I'll show it in red so you can see what we did. All I did was swap these 2 rows.
So why wouldn't we just leave it the same? It's the same equation.
Yeah, technically it is. But remember what we said, what our goal was to make these into zeros. I'm just trying to make it look like what our goal was. But you're absolutely right. You just need 3 zeros, right? Because right here, z is equal to 3, right? And then you could plug it into here, then back up to here. The only reason that I just flipped them, and you're absolutely right, you could. The only reason I flipped them is just so that it looks like that. That's the only reason. It really doesn't. Okay?
Yeah, I got a question.
Go ahead.
Go back down. Okay. So if we left it
Like this?
yeah.
Yeah.
So would that be
Yeah, this would be fine. It would give you the same exact answer. No, it would still be z. Because it's the first column is x, the second column is y, and the third column is z. All right? So this is 0x, this is 0y, and this is, and this is 3z. Okay? Yeah.
so before I even start doing all the math, if I see an easier way for me to
Yes, there's not just one way to do this. If you see that you don't have to flip the second and third row, that's fine. If you see that you might have wanted to multiply that by a half, I think that'd be harder. But if you wanted to, it would still work. There's a bunch of things that you could do it a little bit differently. Okay?
I mean, you know how you flip them, right?
Yeah.
You flip the one on top.
Yeah.
Before I even do any of the math, and if I see an easier way to do it, can I move one? If I move the first row,
You can exchange the rows. You can flip the rows. Yeah, exactly. Because look, x plus y is the same thing as y plus x, isn't it? Okay? So really, I'm taking all these x's and y's, and these x's and y's and z's, I should say. And if I just flip it, all it's doing is just changing the order that I add things. All right? And the order of addition doesn't matter, does it? All right? That's why you can flip the rows like that. That's why you can exchange the rows, I should say. Now, you could if you wanted to. It just depends on your situation, where your zeros end up, Depends where these numbers line up, that kind of thing. Like right here, you could have done this. You could have multiplied the top by a 3, right? And then added it to this, right? And then you could have got a 0 there. So there's several ways to do this. There's not just one way to do this, all right? Okay.
would it just have to be in that bottom fourth corner for those zeros?
Here's what you need, no matter which order you do things in, you need one row that has 2 zeros in it, because that gives one of your variables by itself, okay? And then one row with 1 0, and then the other row with no zeros.
So the order of which one I do doesn't matter.
That's correct. Okay? So let's see what we have here. Now, we're actually going to combine, on this method, we're going to combine matrices, and then we're going to kind of go back and do it like a hybrid, right? And do the other way with x's and y's. But we're going to continue this tomorrow. We're not done this yet. We still got 7 minutes, okay? But we're going to continue this tomorrow, and we're going to eventually make all of these into ones and everything else into zeros. That way we can just look at it and say, oh, x is equal to this, y is equal to this, and z is equal to this, all right? But we're not going to do that right now. We're just doing baby steps right now, okay? So what is z equal to? Because this is z. Remember, these are x's, these are y's, and these are z's right here. So z is actually not just z. What is it? It's 3z. It's 3z is equal to what? Well, I'm all ready to just get z by itself right now. I mean, you could do some more stuff in order to make that a 1 and all these zeros and all that kind of stuff.
So that line is separating the answer, right?
Yeah, this line separates what x plus y plus z is equal to. So
3, 3. So I'm looking at that.
see, it's this. This is where that bar is.
So, so for that 3.
So this means this. It means
3z.
3z equals 3. Yeah, that's exactly what it means. Okay? So that's what we're going to do right here. If you wanted to, you could do this. Watch. Put z's in here. I think it'd be kind of a waste of time, but if it helps you understand it better, you could do that. That's why I put the x, y, and z on the top. So that's a x, that's an x, and that's an x. Does that help a little bit? So that's what that means right there. So this means 3z. Of course, 0x is just 0. 0y is 0. So I'm just left with 3z equals 3. You can do the math really easy now. Z equals 1. So I've got one of my answers. Now, the dominoes just fall now. All right? So once I know what z is, what does this thing right here say? What is this one? What does that mean? That means negative 3y plus z, which is what? 1, because I already know that. I don't need to put parentheses around that. Equals what? Equals 7. And now I can just do my math. Subtract 1. That's negative 3y equals 6. Y is negative 2. Now I know y and z, so now I can come up to here and I can replace my x. Well, you're going to solve for x, so you just keep it x. I can replace the y with a negative 2 and replace the z with a 1. You see that? So what am I going to get now? I'm going to get 1x, or just x, minus 2 times y. And my y, I just figured it out. It was negative 2, so it's just substitution, right? Minus 1z, or just z, which is 1. And that should equal what? 6. And now I just solve for x. So this is x plus 4 minus 1 equals 6. This is x plus 3 equals 6. Subtract 3 from both sides, and x is what? 3. And there's your answer right there. Again, this is kind of a hybrid. It's not full out, Gauss-Jordan. Okay, I think they call this the Gaussian elimination, just the Gauss part of it, just so you can get one of them by itself pretty easy. All right, but you could continue. Like, a lot of people don't like all the x's and y's and z's, right? They would rather have a whole bunch of numbers and do a whole bunch of stuff with it, all right, in order to get that. So that's what we're going to do tomorrow. But there's your answer. So your answer technically should look like what? In order, triple. So it's 3, and then it's negative 2, and it's positive 1. So that technically right there is your answer in that box. Yeah.
So like this is like what the third way you saw it, right?
Yeah, substitution, elimination, and this Gaussian thing.
So
Yeah.
on the quiz, right?
I'll tell you.
Okay,
I'll tell you, solve this by substitution or solve this by elimination. And I have to look at your work and see that you solved it by that particular method.
Like
So
the Gauss method or the
because there's one
Gauss
that's similar to this, but it's not Gauss.
Yeah, the one goes all the way with all the ones, right? This is going to be all ones and everything else. That's the Gauss-Jordan. Yeah.
he's saying, like,
So,
I was gonna say, I think what he's saying is there's two parts, and there's solving the one part, but like on the quiz, where the part where we have to solve with matrices,
Right.
is there going to be, does it like, can you solve using either method, or is it going to specify use the Gauss-Jordan method?
Yeah, that's what I said. I said it's going to specify. Yep.
Gauss-Jordan.
Yep. It's going to specify which method you're supposed to do it. Okay? So just sneak preview. We're going to do that same problem. So keep it in your notes. We're going to do that same problem, but then we are going to do it and get what? Ones here and a 0 here. And then the bar, and then whatever. We'll just call it X, Y, and Z. Okay? So this is what we're going to do tomorrow. This is the Gauss-Jordan elimination method. I think I'm getting those right. I think the way we did it before, the kind of the hybrid way, I think they call it just the Gauss method. Okay? That's what I've seen. And then this is eventually what we're going to get. We almost have half of it, right? What we finished today. But you might, and we had that to be a 1. I don't think we had those to be 1s, did we? This is kind of messy. Yeah. So we had a 1, a -3, and a 3 here. So tomorrow our goal was to make that a 1, that a 1, this is 0, this is 0, and this is 0. All right? So there's a little bit of work to do still. Here's what I did. Can you see the paper? This was the whole entire Gauss-Jordan method right there. Okay? So it had some of the same parts as we just finished doing, but then it does it a little bit more. All right? And the nice thing about this, the Gauss-Jordan, is this. Look, these are just numbers right here. So what is this? This is 1x, right? So this means x equals whatever. What does this mean? This means y equals whatever, and this means z equals whatever. Okay, that's why it's nice to do it this way, because you could see it like just pop out right in front of you. Okay? Did I give you any homework tonight? I did.
It says on the plan.
Yeah, try to do as much of those as you can, okay? All right, 29 to 34. That's your homework. 29 to 34. It's on the lesson plan that I gave you.